So don't panic. Just take the right measures.
There are ways by which an existing house can be made earthquake resistant. Any qualified structural engineer can advise you on this. For masonry structures, retrofitting can be done in the following manner. Improve the strength of walls by cement or epoxy grouting. In the case of stone walls, stitch the walls with through stones or steel bars. Attach wire mesh to the face of the wall and cover with plaster. To understand this better, let's go to Radhanpur in Gujarat. Here, people from nearby villages and towns are gathered to see how stone or rubble masonry construction can be retrofitted.
लेकिन वो ये देखने में आ रहा है कि
No.
this particular specimen here is as traditionally built. So the traditional masons and carpenters were employed to construct this. Exactly similar was constructed the other one. After doing the construction similar like this, that was retrofitted by applying certain elements. This is the condition, this particular specimen on the point of total collapse, whereas the strengthened one is still standing. This is a very interesting phenomenon which always happens in stone masonry, that there are two layers of stones, one inside, one outside. At the time of shaking, the two tend to separate out and one of the layers tend to fall out. Now this is the weakness that must be safeguarded against. What do we do that? As you see here, these header elements, they were incorporated after the model was constructed. How they were constructed? A hole was made through and a steel rod was placed inside and concreted. So this becomes an element which connects the outer layer of the stones and the inner layer of the stones. Now in this case, that particular happening will not take place. Another element that was incorporated here is this, which we call seismic belt or bhukampiya patti. Now this is installed afterwards by using a weld mesh or iron jali, which is fixed to the wall by means of nails or other fixing elements, and then this mortar is applied. Mortar has to be strong, at least 1:3 cement and mortar. Once we do that, then all these walls are integrated. Now there is another element that we have provided in this house that is to be seen from inside, not from the outside. That is a vertical reinforcing bar which goes at the corner of the two walls like this, and it gets connected to the foundation, connected to the roof. Now there are 4 such bars, one at each corner. So now 4 vertical bars, this seismic belt, these header stones, now they make this house earthquake safe. In addition, where we have these triangular walls at the top, those also have to be enclosed in this same bhukampiya patti system. So this triangular wall also does not fall out. Now another detail that you see here is that when we do this, the wooden rafters are now held down to this bhukampiya patti. So even they cannot be displaced by the earthquake. Also during cyclone, this roof cannot fly off. So in one go, we have taken care of the cyclone safety as well as the earthquake safety.
For the retrofitting of RCC-type buildings, the following guidelines should be applied. Visual inspection by an expert to identify the visible weaknesses of the building and requirements of in-situ testing and detailed dynamic analysis. A detailed dynamic analysis based on the actual in-situ strength of concrete may be performed to locate weaker members. The weaker members may be strengthened as mentioned earlier. To increase the strength of beams and columns, extra steel should be placed and jacketed with extra concrete. Steel jackets may be provided to columns and beams to improve the ductility. In the case of buildings with stilts, increase the column and beam sizes to avoid a soft story effect. Some RCC walls may be added at the ground story in such a way that these do not hinder the usage as parking.